Real number reasoning. Our goal today is to understand that every number has a decimal expression. We want to know that irrational numbers are defined as non-repeating and non-terminating decimals. The essential question is, how can you identify if a number is rational and irrational? You should be taking notes as we go through and define and classify the real numbers. Rational numbers are numbers that can be written as fractions, where a over b are integers. Irrational numbers are numbers that cannot be written as fractions. There is no pattern, which means they're non-repeating, and it does not end, they're non-terminating. So the real numbers are divided into two categories, rational or irrational. We're very familiar with rational numbers. They are numbers such as integers and whole numbers. So here you'll see some classifications. Take a moment to make a note of what numbers are rational and what numbers are irrational. All right, so here's some examples. Let's classify these numbers. If I look at the first one, 0.353535, it goes on and on forever, but I also notice that it has a pattern. So this is a rational number. Going to the next one, 25%. I can write 25% as a fraction, 25 over 100, so that is rational. 12 over 3 is a fraction, so it's rational. That's easily spotted. So again, our rational numbers are really easily spotted because they're numbers that we know. Irrational numbers are a little bit different. So the next one, 2.0934, on and on and on, it's non-terminating and it's non-repeating. This is irrational. 1/2 pi. As I mentioned, pi is an irrational number that we know. It does not repeat, 3.1415, on and on and on. And it is non-terminating, so even half of that will be irrational. 5 over 8 is a fraction, so that is rational. Pi, again, it is irrational. 2 and 5/6 is a mixed number, but because I can write that as an improper fraction, that is rational. So we could continue to go through each one of these, thinking about the reasons why it would be rational or irrational. I'm going to stick with the irrational numbers because I know that there are at least 5 more left. So as I scan the next row, the next irrational number I come to is 124.9127. There is no pattern and it does not stop. That is irrational. The next irrational number I come to is the square root of 13. Square root of 13 is not a perfect square, so it is irrational. It will not stop. It does not repeat. It is irrational. Whereas square root of 25 equals 5. That is a rational number because this is a perfect square. 10 pi. So I look at the next row. 10 pi is irrational because it is pi being multiplied by 10. It's still going to be a number that goes on and on forever that does not have a pattern. The next irrational number is negative 0.10110. This goes on and on forever. There is no pattern. 6.9, of course, is rational. It's a decimal. It terminates. I could write that as a fraction. The last irrational number in this chart is 0.1, 0.1 going on and on and on. It does not repeat. There is no evidence that the next number is 1. It's just saying that it goes on and on and on, so that is irrational. So for this chart, and for most numbers that we're familiar with, everything is rational if I can write it as a fraction. Anything else, if I cannot write it as a fraction, it is irrational. All right, so next you're going to practice classifying numbers as rational or irrational. Please review this video if you need more help.